Good morning, good afternoon, good evening, wherever you are. This is Marcus Chow. It's a great honor for me to be the host of this session. Uh, I'm pleased to introduce Professor Josh Hong. He is one of the pioneers to bring the LPPD into campus and sets it a credit curriculum in engineering schools. Josh not only teaches the students the concept of lean product and process development, but also coaches them to apply the LPPD methods to help the sponsoring companies to resolve their PD product development problems. This academic and industrial collaboration enhances the relationship building and achieves mutual benefit. I'm pleased to present Josh Hong to share with you a motorcycle helmet product development story. Josh, go ahead.
Thank you, Marcus, for the kind introduction. And first of all, I want to say hello to everyone from different parts of the world. My name is Yu-Hsiu Hong. You can call me Josh. And it's my pleasure to be here today. And I am a professor in departments of industrial design at National Cheng Kung University at Taiwan. And I am also the director of the Lean Product Development Center at the university. And our Lean Product Development Center was founded by Lean Enterprise China and the university. And the aim of the center is to help companies, mainly in China and in Taiwan, to implement Lean and Lean product process development. And today I'm going to share with you our recent projects in LPPD with a helmet company. And the topic is optimizing PD process, a helmet design case study. So before I do my presentation, let me give you an idea of the case company, Zeus Helmet. And Zeus Helmet is actually the largest helmet manufacturer producer in Taiwan. And it is a OEM, and also it is a ODM. And the company was founded in 1988. And Zeus has more than 1,000 employees in the world. And they have 2 production factories in Taiwan and in Vietnam. And they have sales offices in Asia and in Europe. And Zeus has 4 product brands, as you can see in the slides. They have 4 brands, and 3 of the brands are in Asia. 1 is in Europe. And Zeus has 4 product development capabilities, including the R&D. They have R&D team. They have the helmet safety standard testing lab. And the company even has its own tooling factory. So the company has 4 product development capabilities. So Zeus helmets, they are very strong at manufacturing capabilities, and they have a very solid reputation for product quality. So that makes the company being able to have a lot of business with different clients in the world. And the company primarily manufactures 8 types of products, as you can see on the slides. So depending on the customer's requests, most of these products can be open face helmets, full face helmets, or the adventure helmets and jet helmets, and so on. And so depending on the customer request, most of these products can be made using either ABS, fiberglass, or even carbon composites. And Zeus helmets is also very strong, very good at tailoring product details to meet the needs of its target markets around the world. So, Zeus helmets started its lean journey in manufacturing in 2020. And in 2021, the company realized that there's a need to do LPPD to overcome their challenges especially in the European market. So the company CEO came to me, and so we talked, we discussed, and we launched a LPPD project. And in 2021, it focused on developing product innovation using LPPD principles. And because of the success, our success in 2021, so in 2023, we launched the second LPPD project. And this project focus more on optimizing product development process using LPPD. So my presentation today is going to be the project outcome in 2023. And if you are interested in knowing the project outcomes in 2021, we actually did the presentation. I actually did a presentation in 2021, Lean Global Connection, and you could check it out at the LGC's YouTube channel. So why Zeus helmet come to us? So actually in recent years, the company experienced challenges from the market and the world. And the first biggest challenge for them was that the helmets has become a product in the fashion industry. And so the product has a shorter life cycle than before. And the second challenge they have is that in B2B, helmets manufacturers, they compete through short order delivery. So in order to survive, and you have to deliver design and orders, products faster than your competitors. And so the third challenge is that the number of OEMs and ODMs in B2B, especially in the helmets industry, has increased. The number has increased. And the last big challenge of the company is that the customers' needs are changing faster than ever. So the company needs to respond faster to the changing needs and keep up with the customers. If you are slow, you'll be out. So facing those challenges, and let's look at the slide in the bottom. So the current status of Zeus helmets product life cycle. Okay, so from the left, new product planning, all the way to the right, to the end of sales. So the total time is about 3.5 years. So the time is very long, as you can see. And the time for products development occupies over 50% of the product life cycle time. So it means that the time for making money in the market is relatively short. So from this figure, you can see that if we only do lean manufacturing, it does not really significantly impact the duration of product sales in the market. So now you really see the challenges is really big for this company. So the challenges actually come not only from outside the company, but also from inside the company. So let's talk about the lean LPPD transformation, especially. So the first challenge, internal challenge, the company was facing at the time was that the company they face succession challenges during the transition from the first generation to the second generation. So because the leadership changed and there was resistance to change, especially among the senior management and employees. And the second challenge is that for this company, for Zeus, the development of a helmet is quite complicated, not like the normal products. So it requires not only the involvement of the marketing people, sales people, and manufacturing people, but also for R&D side, it needs the involvement of the people who develop outer shell. And it needs to involve people who develop the EPS foam liner. It also has to involve the people who develop comfort padding. And so therefore, to involve all related departments into product development actively was very difficult for them. And then the third big challenge is that even though the company is the biggest manufacturer in Taiwan, but in its company history for decades, they seldom conducted product development kaizens. So they are not very experienced in making continuous improvements and Kaizen activities. So therefore, gathering people from different departments and to sit together to review the process, it's really difficult for them. They don't have these experiences. And the last challenge is for Zeus is that they have silo problems as well. So there was little communication and collaborations in the company, and most of the time the issue of distrust and conflicts exists among departments. So we observe that the work culture in this company strongly favored keeping status quo, don't change anything, avoid change. So this is the culture in the company. So from this slide, you see the internal challenges, resistance, and previous slide, we saw the external challenges. So next, I'm going to describe the efforts that we put to help the company do the LPPD transformation. So in order to overcome the challenges and resistance and to successfully enable LPPD transformations, we adopted not only top-down, but also bottom-up approaches. So the first of all, because CEO's commitment to LPPD implementation is very critical. So we asked the CEO, I particularly asked the CEO to physically participate in all LPPD training, workshops, and Kaizen activities. That's really a key element. And I also asked the CEO to designate a top management person as the lean advocate to encourage making improvements, to facilitate cross-functional collaborations, and to in Kaizen and to make things happen when things get stuck. So this advocate serve as the interface, especially there are conflicts and arguments. And this advocate also serve as the interface between the CEO and the engineers, designers. And next, because of the CEO's attendance, so you can see in the picture, we were able to have all functional departments actively join LPPD Kaizen at Gemba. So So because of the CEO attendance and after we making sure that all people will come and they are willing to contribute. So that moment we introduce value stream map to visualize the problem in the product development processes. So we actually ask the functional departments to indicate the issues they observe with each other. We ask them to discuss the issues they observe each other, and we ask them to talk with the management. And so these interactions help us see a lot of issues and problems to solve. At that moment, we introduce the A3. So encourage the ownership of Kaizen, and most importantly, to develop people. And we ask those who were in charge of A3 to present their team's Kaizen. So as you can see at the bottom right, so we ask people to stand up and to do presentation, share with people about their Kaizen. So this slide shows you the VSM, value stream mapping of Zoo's new product development. And creating this map was really a teamwork. So it cannot be done without the improvement of all related departments in product development. So this map also gives people a general idea of what really happened in typical product development, what problems cannot be ignored, what problems should be fixed as soon as possible. So it really forced people to think about who should talk to whom in product development, and also forced people to think who caused the problems to whom. So this map encourage conversations, discussions, and forming consensus to the solutions. So the Kaizen team ended up identifying 3 areas that have significant waste. So they are the lead time for outer shell mold development is long. The second is lead time for developing an engineering pilot run sample is long. And third is the lack of standardization in new product planning. And today, because of time, I'm going to focus on the first 2 areas in this presentation. So regarding the problem of long lead time for outer shell mold development, so Ruth's Kaizen team did a Gemba work. And so they saw the problems in the work management of outer shell mold development. So for example, in the slide on the left, you can see that the different types of work orders stack on the table. So it took time for the manager to find one specific order. And if specific order was accidentally stacked at the bottom, and this order would not be completed unless someone brought it up. So before Kaizen, and also another big problem is that the scheduling was very challenging. So, and because rush orders could come in different times, so oftentimes those rush orders mess up the original work schedule easily. And because scheduling was challenging, so prediction of work order completion time had been very hard for managers. So what could the management do to fix the problem? So let's look at the slide on the right. So after Kaizen, we work with the Kaizen team of Zeus helmets, and we created a visual work management board where people can see the workload of each engineer and see where the order is in the process. And for rush orders, they were color-coded and couldn't randomly go into the work management board. So the team managed to develop 2 versions of visual work management board, as you can see in the slide. So benefits are the work order scheduling becomes easier, predicting order completion time become easier, average lead time for each work order was shortened by 37%. And regarding the problem of long lead time for developing an engineering pilot run sample, we work with the Roots Kaizen team, and we review the product development processes together. And we found that before Kaizen, so the padding design team took 5 months to complete a padding sample, which is very long. So how was that possible? Why it took such a long time to create a padding sample? So we used the 5 whys and we identified the root causes. And we found that a padding sample has to be completed by the padding production team in Vietnam, not by the team in Taiwan. So the purpose was to make sure that the mass production of padding would not have problems. But however, the problem was that the Vietnam team, production team, cannot make a padding sample in one time that satisfied the Taiwan team's expectations. So therefore, it took a lot of time sending the padding sample back and forth from Taiwan to Vietnam, from Vietnam to Taiwan. So it really experienced why the 5 months it took so long. So why couldn't the Vietnam team meet the expectation of Taiwan team? So it was because the Taiwan team only gave them the padding sample they made without giving any additional instructions. So therefore, to fix the problem, we suggested the Taiwan team must provide SOPs, instructions to the padding production team in Vietnam, so that the Vietnam team can create a good quality padding sample in one time. So our suggestion reduced the waste of time by 1 month. So that's the first waste that we saw, and we try to fix it. So you can see the before Kaizen is about 12 months, and we reduced 1 month, especially for a pad making. Amount of time is 1 month. And next, the total lead time for making engineering pilot run sample went from 12 months. Now it went down to 11 months. So Ruth's team continued to review the process to identify the waste. So they found that the EPS team, you can see on the slide, did not start its work simultaneously with the outer shell team. And also you can see that the padding design team did not start their work until they get a notification from the EPS team. So we asked the 3 teams to sit down and discuss why they couldn't do their work simultaneously. So the answer was that the helmet spec and dimensions. So the EPS team, they need the specs and dimensions of the outer shell to start its work. So therefore, the EPS team cannot work until the outer shell sample was produced. And the padding design team, they need the spec and dimension of the EPS to start its work. Therefore, the padding design team cannot work until the EPS sample was produced. To remove the unnecessary waiting, so we asked the outer shell team to provide the specs, dimensions to the EPS team once they finish their 3D design, because the dimensions and spec were all shown in the 3D files. So we also asked the EPS team to provide spec and dimensions to the padding design team once they finish the 3D design. So this Kaizen successfully reduced the waiting time and reduced the total lead time from 11 months to 4.5 months. To conclude, so the Zeus Kaizen team made achievements mainly in new product developments and the lead time and people development. So as you can see in the table, the team successfully developed SOP for new product development, and they also eliminated the waste time in the design and fabrication of a comfort padding sample from 5 to 4 months. They eliminated the waste time in developing the sample for engineering pilot run testing from 12 months to 4.5 months. They also eliminated the wasted time in the outer shell mold development from 4.25 months to 2.75 months with the visual work orders management board. So total improvements on new product development lead time is about 10 months, from 34 to 24 months. So it increased the 10 months for the company to sell the products in the market. So it was a 30% reduction of the total product life cycle time. And the second conclusion I want to make is that the project was conducted through industry academia collaborations on LPPD. So this means that academia, universities could help promote lean thinking practices as well. So in addition, from the slide, you could see that the university on the left and Ruth's team on the right. So in university, we develop the core TPS, LPPD concepts, knowledge, tools, methods. And the Ruth's team, they learn from them and they improve their organization performance in product development. And at the same time, the Kaizen culture was developed. So this collaboration not only enable development of product development knowledge and people, it also allow university to learn how to install TPS successfully in companies and in the field to improve the organization performance and the Kaizen culture. So it is our hope to promote and expand this collaboration to a larger scale in the future. And this is my last slide. So to finish my presentation, I would like to say that the world is changing really fast. And I will encourage you to join us, to join our efforts in developing adaptability to a changing world with Lean and LPPD.
Thank you, Josh.
And this is my presentation. Yes.
How long does this project take you and your student?
About 6 months.
6 months. So it's
Yes.
6 months as a part-time, right?
Yeah, students after finish these projects and the student graduated and now the students got the full-time job in the company.
Wow.
So we
That's a
developed
plus.
the people in the company. Yeah, we also developed the students.
Yeah. How much time you have to spend on this project?
I need to meet with the students every week, and I visited the company every 2 weeks. And if there's a need, and I will visit the company. So it's a lot of efforts because our intention is not only introducing LPPD tools, but the most importantly, we want to change the Kaizen culture. So if any opportunities showing up, then I will really take the chance and to explain everything and how to move from this step to next step. So it takes a lot of time. And the benefits of having students in a company is that the students can monitor things going on in the company and report to me right away. So I can understand the situation and LPPD activities in the company.
Thank you. I think our time is up. Thank you very much for sharing.
Yes.
And I think it's a
Thank you very
great
much.
story. Yeah.
Thank you.
Bye.
Thank you.